Okay, so I think we're going to start. So welcome everyone to this week's webinar. What we're going to look at today is machining made easy with Fusion. So we're basically going to look at how Fusion 360 can be used to create NC code, which is used on CNCs to do machining, like you can see on the slide. My name is Jonathan Kruger. I work for Moderna Design Centers Durban. I primarily focus in Fusion, Inventor, Volt, and Plant 3D. With that out the way, I'd like to switch to the software where we can look at using Fusion with the CAM. So I've switched to Fusion. And what I've got is I've got the simple part that I want to machine. And what I want to do is I want to basically switch on. So I've already pre-positioned a vise, which I would be using for this machining to hold the stock. So I've already got a vise here. I'm just switching it on. We're going to use this for the purpose of having the job held in the correct position. And then that way, if we machine the vise, we know that there's something wrong and we need to change our code. So this is Fusion 360. Hopefully everyone's seen this before. You've got several different environments, generative design, which Yashin has looked at, and we're going to look at the manufacture. So we're going to switch to manufacture. And here, like all Autodesk softwares, you pretty much just work left to right. So I'm going to start by creating a stock. So the stock is your starting material. Now, because I've got this vase, the program thinks I actually want to machine the vase also, like I'm trying to create the vase, which isn't the case. So I'm going to change that to the model to being just the parts I want to machine. You'll see you can choose fixtures, and I'm just going to choose the vase drawers. And what this allows us to do is when we're doing the machining, if the cutter hits this fixture, it's going to be detected as a clash, which is something you really do want to happen. When you're machining, you don't want to be machining your jaws unless you were using soft jaws, which are jaws they basically do machine. So I'm going to switch to stock, go to my offset, and I'm going to give it an extra 10 millimeter. And you'll notice if I look from the side, that 10 millimeter has basically gone over here. And I wanted 10 mil, so I've on purpose positioned this to be 1 mil over and 10 mil down. But it thinks 10 is going this way, and that's because of the axis over here, your origin. So this is your cutter's position, and right now it thinks Z is going in this direction. So when you work with normal 3-axis CNCs, your X and Y is the bed movement left and back and right and forward, and the Z is the head. So it thinks the cutter is coming from the right-hand side. Now, if I hit the arrow, it will go the other way. And if I click on the little axes, I can actually click on a face and the part will invert. So what I want is I want the Z to be facing up. I'm going to go on the corner. And now you'll see that basically on the front left-hand point of the model, that's where you would zero the CNC. So I've got that all set. So I'm going to click on OK. And you'll see now if I look from the side, the 10 mil and the 1 mil that I gave is now fitting perfectly with how I positioned the vise. So obviously you would have to position the part to suit before you start this. All right, so with this, I'm going to move straight into the face, basically operation. So this will use like a rose cutter to finish the top. So I'm just going to go and select the tool. So here you've got your library of tools, and you can do little searches. Like if I say ball, there's all your ball end mills and all of those things. But for this example, I've basically added libraries here. The reason why it's not coming up is I have ball filtered. There we go. So I've created a little library where I've copied all the tools I want to use to do this machining operation. So I'm going to click on the 50 mil face mill. You'll see you have a jar. It's quite easy. You can actually edit the tools, which comes in here. And if you go to cutter, you can control. It's all very user-friendly. You'll see when I actually select any of these values, it actually shows you which part you're editing. So they've made this part of it really, really user-friendly. So I'm going to double-click on that tool. Pulls it into the job. You can see the orientation is correct, and that's got to do with me setting the X, Y, and Z. And face operations are fairly easy. I don't have to actually do anything. So even though I've chosen 2D, I just hit OK. I don't have to select anything. And the program goes and does it. Now, this is actually a change in Fusion that happened in the last 4 or 5 months, where when you create an operation, it actually shows you a preview of your stock. So the green is the stock, and it's pre-machined. You'll see if I deselect off that operation, you see the original block. If I look from the side, you see the block is higher. If I select that operation, you actually see what that operation has done. So that change that they've done to Fusion has really made it a lot easier to see what's been done and what still needs to get done. So with that out the way, what I want to do is I want to machine this little section over here. So this thing that looks like a little smiley face. I'm going to choose 2D adaptive, and we get 3D and we get 2D versions. Now 2D operations, you select edges, and based on what you select, it will work with. 3D works on your 3D model, and then you use containments to keep them machining what you want. So a lot of stuff you can actually do just using 2D operations. So I'm going to select the inside of this. Now, obviously, my tool is a 50mm face cutter. It's a little bit big. That won't fit in those areas. So I'm going to still change it to an 8mm bull nose. I'm going to select it. So as you can see, that changes over here. And I'm going to just click on OK. So a lot of these things you can normally just click on OK, see what it does. And based on what you see, you can then change it. So let's look at this adaptive clearing operation with the simulation. So I'm going to start the simulation. Okay. When I go into the simulation, you'll notice that I don't see the stock. So I'm just going to put the stock on. That's the material. And if I press play, the program will show me what that machining operation looks like. Now, I know with Zoom, there can sometimes be a little bit of a delay. It might be a little bit jerky. So I've tried to just slow it down so that you can see what that looks like. So that's the cutter taking the material away. I'm not too fussed about that. I'm going to skip past it. And then there you go. The cutter's coming in. It's doing a spiral. And I just want to get, there we go. So I'm just going to slow this down now. So this is using something called adaptive clearing. And what that does is it takes a constant load on the cutter and it takes more face cutting. So it's not using just the bottom 2mm of the cutter. It's doing like a 10mm cut, but it's taking 30% of the cutter, putting it under a constant load and then clearing that material out. So I'm just going to stop the animation. Let's just speed it up a little bit. Just going to take it to the end. So that's what it would then look like with it machined. So looking at this, I might think, well, maybe it was machining too much. Maybe I don't like when it comes into the parts, it's doing a spiral. I want a taper spiral. And the beauty of this is you just literally edit the operation. So I've just clicked on edit operation. I'm going to passes. And the first thing I wanted to show you, which is really neat, so the optimal load is that adaptive clearing. So this comes from the HSM, which stands for high speed manufacturing. You'll see at the bottom it says no HSM, it's just a high load, but with HSM enabled, it's minimum load, basically giving you longer cutter life because you're using more of the cutter, but not heavy load. It's constant small load. But I might not like the amount. And what's pretty cool, this is you can actually, it's just an expression. So it's currently set to 0.4 of the tool diameter, which means 40%. If I put 0.3, that'll take smaller cuts, so 2.4, which is 30% of the 8mm cutter. The next thing I wanted to look at was linking. So as you basically see with this, you can work your way left to right. We'll look at all the different tabs as we go through the examples. So for this one, the passes is your machining operation and linking is how it goes from one operation to the next and how it gets to its spot. So I wanted it to spiral in, so I'm going to change the ramp to have a taper angle of 7. Click on OK. And you'll see the little preview now has a red spiral going in. So I'm not going to animate that because there's no point of seeing it machine, but you can see now the tool path. It's going to spiral in, taper itself down, get to the bottom, and then use that high-speed machining algorithm to take the rest of the material off. So once that's done, I want to finish this inside shape. So I'm going to do a 2D contour to do that. So just like before, I select where I want to machine. So I want to machine the inside over there. I'm going to change my tool because an 8mm bull nose has got a little radius at the bottom. I'm going to change that to be a 10mm flat end mill. So I've changed my cutter. You can see the little representation has changed. The geometry is the bottom, and I'm just going to click OK to see what it does. And this is what I was saying is the beauty. You just click on OK, and then afterwards, if you think there's something you need to change. So as you can see, it's doing it in one operation. There's a yellow line going down. You'll see then it leads in, machines its way all the way around, and then it leads back out. Now I might want it to do two of those because I'm taking the model to size. So I'm going to edit this operation, and I'm going to change it to have some extra passes. So I'm going to go to the passes tab, and I'm going to put multiple finishing passes on. So I've put this little tick box on here. I'm going to say 0.6 is the maximum material it can remove at any one time and leave it at 2. So what's going to happen instead of one line running around, there's now 2. So it takes one small little cut and then it leaves 0.4, which it then does on the second pass. So that's that one done. Now I'm going to use this same cutter to machine the outside of this shape. So I'm going to use the same thing. I'm just going to switch over here to, and you'll notice the whole time the model sort of changes to stock and then disappears. All that's happening there is I'm just deselecting this. I'm not pressing any fancy buttons. When I just press escape or deselect, it'll show you your model as it is, not the machined variant. So I'm going to do a 2D contour. Now, normally with something like this, you would select the bottom edge, but I'm actually on purpose going to choose the top edge to show you how the 2D differs a little bit from the 3D. So with that selected, I'm not going to change any settings. I'm just going to click on OK. And as you can see, it's just machined this area here. So it's not actually machining below the edge that I selected. So I'm going to edit that operation. And you would have also noticed it's doing one pass over the whole model. It's not taking it down. So that's quite a lot of material to machine in one step. So I am going to change the height. So that's why I said we are going to look at this. So tool is the tool that's doing the machining. Geometry is what we're machining. We're going to change it to heights, and we're going to say that the bottom height isn't the selected contour, and that's why it stopped. I want this to be model bottom. Now, the reason why I'm choosing model bottom and not stock bottom, actually, let me choose stock bottom. Let's put -2. And what's going to happen, stock bottom, it's going to machine lower. I can show you what that fixture does now. So we're going to say, okay, let's first just go to passes. I'm going to have just 2 roughing passes here. So I'm going to set that to 2 and 1.5 millimeter is the maximum material. Click on OK, and the model will do 3 cuts. So just now try to do it in one. So now it's doing roughing, and then the finishing cut. But you'll notice it's cutting right through the jaws. Now you can actually see this in your simulation. So I'm going to just click on the setup at the top, start my simulation. I'm going to skip. So this here, you can go to the next operation, go to the next operation. And I then want to see it do the last one. And if you look at the bottom, you'll see these little red lines. That's each time it hits something. And what you can do is, mine is on already, but it says stop at collision. So it's going to play. Okay, it's doing the cleaning of the inside. Okay, there you can see it's finished that. And you'll see it stops and the whole tool has gone red. That's because it's trying to machine your jaws. So let me just fix that quickly. So I wanted to show you 2 things that you can change between them. So in this case, I actually want to use the model bottom because my stock's got extra material, which we machine off later. And I want this to be -1.25. I can verify this by looking from the side. You can see this blue work plane represents the bottom of the machining and it is above the cutter. So if I click on OK on that, I go to my simulation. I skip through the first 3 operations and we play now. You'll see it's going to go around the outside and machine it. And it will machine it, like I was saying, 3 steps. So it's going to start rounding that corner off. The next step should start to cut material on the actual part. And then the final one, as you can see here, it's stepped in. No halting because it hits anything. So this is probably as good a time as any to show you some of the options you have with the simulation. So there's a colorization you can use. Currently it's on operation. So you'll see that's purple and that's copper. And if I go back, you'll see the inside would have been a different color. Each machining operation gets its own color. I want to change this to comparison, and that's showing me green is what's done and purple is still needs to be done. Think of it like that. So this is all like done, this is done, but as you can see, we got this purple ball in the middle and we've got the 4 holes, and I haven't done a chamfer. So let's do the chamfer. So with that out the way, let's go and say 2D contour. This time I do want to select this edge. I don't want to use this cutter because obviously to cut a 45 with a flat cutter, you would have to cut, 50 gradients and it'll still be all rough. So I'm going to set it to the 15 mil chamfer tool. And I do need to do a little bit of a height adjustment. So the height is obviously that bottom of it, but I'm just going to say -1. And all that is for is I want my cutter to stop a little bit underneath here. So I don't need to change any other settings. I might want to do the roughing passes like I did. So I'm going to say roughing passes, put it at 2 with the same 1.5 step over. So, okay. And as you can see, it's then doing 1, 2, 3 loops around to get the part. So if I just do my simulation, and you don't need to actually play all of them. Like I said, you can just say go to the end. And as you can see, we can see green's been done, green is good to go, and purple still needs to get done. So now that we've done that, let's drill these holes. So that's drilling operation. So I'm going to click on drill. I'm going to go to select my tool, and same like the other ones, I'm just going back to my library. I'm going to choose a spot drill over here. I'm going to go to my geometry and tell it, right, I want you to spot drill these edges here. And what I found quite neat when I first used this was this little order. You see, inside out by X, or just optimize order. So as you can see, it doesn't matter the order I choose. The program is trying to optimize the movement to suit the holes it's going to drill. If I just look at it from the side, you can see how deep the cutter is going to go in. And all it's doing is it's going to the selected edge. Okay, it's unable to actually do that part. It knows it mustn't try and use it like a chamfer cutter where it would physically machine the edge. It knows it's drilling in. So I'm just going to go to my height, and once again, and that's where this is very handy to do, I'm going to set it to the stock top and just put a -2 offset. So as you can see, it's 2 mil in. I could obviously change that, like let's say -5. As you can see, it would be that deep. And I'm going to click on OK. So there's the operation. It's just going to go in here. So it starts here, drill, there, here, there, and then out. So with the spot drill out of the way, we are now going to look at actually drilling this. So this is where I thought there was another neat feature of this. You don't have to recreate things that you do. I'm going to duplicate this. So I'm going to duplicate this, and you can actually create templates of multiple operations and all sorts of things. We're going to do the simple one. So it just duplicates it. I'm going to edit the operation, change the tool to a drill bit. So I've got an M12 pre-drill over here. So that's just a 10.2 millimeter drill. And I obviously do need to set my heights because currently this is only going to drill in 5 mil. So I need to drill it through the model. But remember, the model's stock is much thicker. So I'm going to go to my heights. I'm going to say, right, I want to use the stock bottom. And I'm just going to look at it from the side. As you can see, it's got the -5 offset still going through there. I'm going to change that to -1. So obviously it's just 1 mil past. So you can see it's 1 mil past the depth. That represents the bottom of the stock. But if I tick drill tip through bottom, it knows to go more. So I'm going to set the offset at let's say -3 millimeters. So I know it's going past the bottom of it. So I know it's breaking through on the other side. With that out of the way, I'm going to click on OK. Now, I could have duplicated the first operation and used it again, but I didn't want to because my tap operation is going to use the same thing pretty much. The only difference is going to be, I'm going to change it from a drill bit to a tap. So I wanted the bottom offsets all to be set. So for me to do the third tapping operation, I've just duplicated it. So here's drill spot, drill tap. The tap operation, I'm going to change it from the tool being the pre-drill back to my library. There's my M12 by 1.75 tap selected. And you'll notice if I go to cycle, it's changed the cycle type to tapping automatically. So the program is pretty clever. When you have a drill bit selected, it tries to do a drilling operation. When you have a tap selected, it knows use a tap operation. I don't need to change any of the other settings. My heights are all perfectly offset. So with that done, let's click on simulate. So I just make sure I don't have any operation selected, or you have the top one. Simulate, I'm just going to go to the end, and this is just to verify for myself what I still need to do. And as you can see, the last thing I need to do is just this ball cutout that I've got over here. So let's machine that out. So earlier I did that 2D adaptive clearing operation to do this. With this kind of shape, obviously I would need to use the 3D adaptive clearing. So I'm going to start the adaptive clearing, and I'm going to set the tool to the same bull nose that I used earlier. So I'm going to go library, 8mm bull nose, selected. Cool. So I've changed my tool, and if I clicked on OK, it would just try and machine the whole part. So I'm going to go to geometry, and you'll see the yellow section there. That's basically, it's saying everything inside of that yellow thing go in machine. The program isn't clever enough to know that, what it needs to do. It can work from the previous setup, but not for everything. So I'm going to manually contain this. So I'm going to change it to selection. I'm going to select select the circular edge there. And I'm going to say that the tool must stay inside. Now you'll notice there's still the outside, and that's because of the stock contours. I'm just going to switch that off. So what happens now is it says in that green thing, that's where you're allowed to machine, and the tool must stay inside of that area. I'm not going to change any other setting. I'm just going to click on OK. So you'll see it'll process. And this is a multi-threaded processing thing. So on bigger operations, it does fully utilize your CPU to process all of these things. So one of the things that I noticed with this is, obviously, if you look at that operation, all those yellow lines up and down, up and down, up and down. So the first thing people always ask me when they start using this is they say, how do I get the tool to just stay down a bit longer? So let's go and look at that. So I'm going to edit the operation and go to linking. So what happens here is the retraction policy is full retraction, and that's why it keeps going all the way up. So I'm going to say minimum retraction. So go, don't retract if possible. And I'm going to change the helix to have a 7-degree taper. So that's going to do that same when it comes in, like I did on this little smiley face section. It's spiraled in. I'm going to have it spiral in on this one. I can have it cut more material. So yeah, you see the stay down, it says least. I'm going to say 90%. So I'm going to say as much as you can stay down. If I go to passes, it also does, so with this being set to 10 millimeter, what it does is the machine's 10 mil of the material, and then it clears it out. Then the machine's another 10 mil down, and then the machines it down. I want it to go down as far as it can. So I'm just going to set this to 25, 20. So the reason why that's going red is your cutter, it's saying that my flute and my cutter doesn't have enough cutter to actually cut to that depth. And that's another really cool thing. You're not going to try and cut with the shoulder of your cutter. So we're going to say okay with 20 being the depth. And you'll see that once the operation is finished calculating, it's created much less up and down. It's spiraling straight into the next cuts. So basically we're spending less time cutting fresh air and more time cutting the model. And with any machining, time is money. You'll also notice if you look next to any of these, there's actually a cycle time. So each of these operations, it says, right, that's 2 minutes, this 1 minute. If I edit this operation and I go to passes, so fine step down is set to 1 millimeter. If I say, right, do it in 0.5 steps, let's just let it process. So obviously it will take longer to process. Maybe I can actually show you the CPU utilization. So you'll see there 40%. Don't think I got it to load up more than 50, but as you can see, there's much more steps going in. and the cutter didn't retract too many times. So what it did was it spiraled right down to the bottom and then it just worked its way back up. All right, so now that's the roughing part of it done. Now this is using, remember when I did this one on step number 2, I used that same 8-ball nose and then I switched to the flat to finish it. Now CNCs, you probably want to stick to the same cutters in the same order, otherwise the machine has to change cutters. So I'm going to drag this roughing adaptive operation and I'm just going to drop it below the 2D one. And the program will then reorder it. So now it's going to do the face, then the adaptive with the 8mm ball nose, then the adaptive here with the 8mm ball nose, then switch to the 10 and start finishing. So it's another nice thing. You can actually change your order of things and see how that goes. So I'm just going to do the final cleanup. So I'm going to use the ramp operation to finish this. I'm going to select a ball end mill. Not that one, sorry. The 10mm ball end mill, there we go. And I'm going to do the same containment. So this is going to be selection, select it over there. Make sure the tool stays inside. I'm going to go to passes. So currently it's trying to do 3 more steps. I'm going to set this to 0.2. I could set it to 0.1. Obviously, the smaller the step, the more cuts it's going to do. As you can see, it processes that fairly quickly. And if I look at my simulation to make sure I don't have any clashes, I'm just going to say simulate. If you look at the bottom, there's no red areas. So that means I'm good to go. And if I skip to the end with my colorization set to comparison, you should see now, because there's so many lines, I'm just going to switch my toolpaths off. And that's once again, that's what's pretty neat with this. You can toggle things off and on as you like. So I can see I've machined it now all the way to the end. What I would then do now is I would obviously turn this around in the vise to be the other way and then machine the bottom off. I'm not going to do that for this instance, but what you would do is you would create a new setup. So it would be a different setup with a different Z direction. So the last bit that we're going to look at here is, like I said, the whole idea of this is to see how you can generate NC code. Well, let's actually make some NC code. So I'm going to first show you what a setup sheet looks like. This is something you could give to the person who has to set up the machine. So as you can see, it says, right, this is the job description. These are the, so that's sort of an example of showing you what the model looks like. It uses the view that you currently had. And then it says, right, these are the tools we need. We need this one loaded in tool 1, tool 3, tool 4. So all of those loaded. And then the operations. And as you can see, because I rearranged it, that bull nose gets used in a consecutively and then changed to a 10mm. Then there's 2 10mm operations, chamfer, and then the drilling operations. So I've got the order the way I like it. And if I want to look at the NC code, we click on the G1, G2 over here, and I'm just going to process it as if it was a Fanuc. Click on post, just give it a location. I'm just going to put it on my desktop. And here is your NC code. And if you look on the right there, you'll see it's quite a lot of lines. So we were able to create some NC code with 26,488 lines of code inside of it. All right. So that's basically it. Any questions from anyone? Okay, well, if there's no questions, thank you everyone for joining us today. Hopefully you learned something about Fusion that maybe you didn't know before, and hope you all enjoyed it as much as I enjoyed presenting.